Welcome to section 16 of KMF 170 puzzle. This section deals with permutation, combination, and probability. Let us start with the first question. The figure above represents a game board with a tip at starting point M. On successive plays, the tip must be moved along the lines from one leveled point to an adjacent leveled point, but may not be moved to the same point twice. Along how many different paths can the tip be moved from M to N in this game? Okay, so to solve this question, we can use the enumeration method. The condition is the point may not be moved to the same point twice. Okay, we cannot use same point twice. So let us see how can we solve it. MPN. This is one path. MPQN. This is another path. In this way, you can find out 5 more paths. So total path is 7. There are other methods to solve these questions. For example, counting method. However, I think that for this question particularly, enumeration method will be easier to use. Let us move to the next question. How many different points x, y, where x and y are both positive integers in xy plane satisfy the inequality x plus y less than equal to 200? Okay, so we need to find out the number of points where those points meet the given inequality. Okay, so there are 200 numbers. But how many points are there? Suppose x equal to 0, so y will be 200. And x equal to 1, y equal to will be 199. In this way, if x equal to 199, y equal to will be 1. So total point we get 199. So using the formula for successive series, that is n into n plus 1 divided by 2, we can find out the total number of points, that is 199 multiplied by 200 divided by 2. So our answer will be 19,900. We are in the third question. A banner is to be designed to have 3 regions of solid color as shown. Sorry, here is no color shown, but there are a banner with 3 regions. Colors can be repeated, but no 2 adjacent regions can have the same color. How many different designs are possible if the colors are chosen from blue, green, red, white, and yellow? The condition is 2 adjacent regions can't have the same color. In total, there are 5 colors that are blue, green, red, white, and yellow. So for the first region, we can have 5 color and we can choose one among those 5 colors. So 5C1. For the second region, we must omit one color. So we left with 4 colors. So choose 4C1. And for the third region, we can have color that we have used for the first region, but given the condition, we can't have the color that we have used in the second region. Again, left with the 4 colors. So again, we get 4C1. Multiply all of the results and you'll get the answer, that is option E, 80. Let's see the fourth question. How many 6-digit integers greater than 321000 can be formed such that each of the digits 1, 2, 3, 4, 5 and 6 is used once in each 6-digit integers? Okay, so the condition is 1 to 6 is used once, and another condition is the 6-digit integer must be greater than 321000. Let us use the counting method. Okay, so in the first case, we have 4 multiplied by 5. Why we have 4? Because we cannot use 1 and 2 in the first place. In case of 3, that is 3 to 1, in case of 3, we cannot use 1 and 2, as using both of these digits will make the integer less than 321000. Okay, so we have left with 4 integers. In case of place that is given to digit 2, we can use 5 integers except except 1. We can use 2, 3, 4, 5, 6. So there are 5 integers. And for the others, we are actually using 5 factorial. So 5, 4, 3, 2 and multiplied by 1 equal to 480. Now notice that in the given integers, that is 321000, 3 is given here. So we can have integer that is greater, for example 321001. So we need to take difference of the integers that are already given in the integers, and we have counted twice. For example, we have counted 3 2 times. When we have placed 4 multiplied by 5, that 4 includes digit 3. So we need to minus it out. In this case, we get 1 multiplied by 1 multiplied by 4, 3, 2, 1. So get 24. Now take the difference, that is 480. So it will be 480. If a set S has a total of 6 subsets that consist of 2 members each, then S consists of how many members? We need to find out the total number of members, and we are given the number of subsets and the number of members of each subset. How can I find it? Total subset minus total number of members in each subset equal to total members. So the subset number is 6 and each member in the subset is 2. So 6 minus 2 equal to 4. That is the total number of members that S consists of. We're in the sixth question. Daryl has a collection of 40 DVDs, each of which contains one movie. There are 17 comedy movies, 14 fantasy movies, and 9 historical movies, where each historical movie takes place in a separate time. The movies will be ordered on a shelf from left to right so that the movies of each type, comedy, fantasy, and historical, are in a single group of consecutive movies. In addition, the historical movies will be ordered from earliest time period to latest time period. How many possible orderings of the movies are there? Okay, one easy way is to think it as a bunch: comedy, fantasy, and historical movie. So there are three types. So you can have the three bundles, like three bunches. So for comedy movies, we have 17 and factorial 17 factorial. And for fantasy movies, we have 14 factorial. And the condition is historical movies takes place in a separate time period. And the type we arrange it in this on the shelf from left to right, so that the movies of each type are in a single group. So in a group there are comedy, fantasy, and historical movies. So 1, 2, 3. So the answer will be 17 factorial into 14 factorial into 3 factorial. We are using the bundling method. We are in the seventh question. An urn contains 4 red balls, 8 green balls, and 2 yellow balls. 5 balls are randomly selected with replacement from the urn. What is the probability that 1 red ball, 2 green balls, and 2 yellow balls will be selected? Okay, 2 points to mention. That is, we will select with replacement, and the probability of selection will be for 1 red ball, 2 green balls, and 2 yellow balls. So let us first select red balls. So 4 by 14. Then we'll select 1 green ball, that is 8 by 14. Each time denominator will be 14 because we are using with replacement. So total number of balls will be 14. Now we'll select another green balls. So 8 by 14. Now select 1 yellow ball, 2 by 14. And again select yellow ball, so 2 by 14. So multiplying those, we got 32 divided by 16,807. Now, this is not the end. We need to select 5 balls randomly. So total is 5 factorial and 2 green balls. Green balls are alike, so 2 factorial, and yellow balls are alike, so 2 factorial. We get 5 factorial divided by 2 factorial multiplied by 2 factorial equal to 30. Now we'll get the proper fraction. 32 divided by 16,807 multiplied by 30 equal to 960 divided by 16,807. This is our probability. Two seating arrangements of people around a circular table are called the same if for each seated person, the same person is seated in that person's immediate right in both arrangements. The number of different seating arrangements of 4 people around a circular table. Okay. So one person has sat down. Among the 4, 3 remains. So remaining 3 persons can sit next to each other in 3-3 order. So we'll get 6. There is an alternative method, we can use it. The number of arrangements of n distinct objects in a row I given by n factorial. So the distinct objects is 4 here in this question, so we get 4 factorial. So the number of arrangement of n distinct objects in a circle is given by n minus 1 factorial. So in this question we will get 4 minus 1 factorial equal to 3 factorial equal to 6. So answer will be B, because quantity B is greater than A. An artist will arrange 5 identical plastic apples in wooden bowls, one made of maple, one of oak, and one of pine. How many different arrangements are possible such that each bowl will contain at least one apple? Okay, there are 5 identical plastic apples, and we need to arrange it in 3 wooden bowls. So how many different arrangements are possible? The condition is each bowl will contain at least one apple. Okay. So as there are 5 identical plastic apples, how can I arrange it? 3, 1, 1. Maple can have 3 apples, oak 1 apple, and pine 1 apple. We can arrange it in 3 different ways. For example, 1, 1, 3 or 1, 3, 1. Similarly, maple can have 2 apple, oak 2 apple, and pine 1 apple. So it can also be arranged in 3 different ways: 1, 2, 2 or 2, 1, 2. So there are total 3 plus 3 equal to 6 different ways. These are some special examples, and you can solve it with simple logical thinking. We're in the last question. The number of ordered triples x1, x2, x3, where x1, x2, x3 are non-negative integers such that x1 plus x2 plus x3 equal to 9. So as these numbers are non-negative, we can use either 0 or any positive numbers. So if x1 equal to 0, x2 plus x3 will be 9. In this way, other pairs can be 0, 9, 1, 8, 2, 7, etc. So at x1 equal to 0, we get 10 pairs. Similarly, at x1 equal to 1, we will get 9 pairs, and it will reduce in successive orders. In this way, we get 10 plus 9 plus 8 and up to 1. So summation of 1 up to 10 will be 55. That is equal to quantity B. So the answer is option C. We can use another method. So whole number solution of an equation is given by n plus r minus 1 combination r minus 1. So n equal to 9, that's the total of summation, and r equal to 3, that is the order triples. So n plus r, that is 9 plus 2 equal to 12, minus 1 is 11, and r minus 1 equal to 2. So 11, 2 equal to 11 into 10 divided by 2. So after dividing 10 by 2, you get 5. So 11 multiplied by 5 equal to 55. So you get answer C in this way as well. That's all for today. Thank you.